So thank you, Martin. My name is Jaya Mathew. Thank you for attending the last session of the conference, and it's been a long day. Thank you for taking the time. I am a senior data scientist at Microsoft. We've been working actively with a lot of external customers. So based on my experience, I kind of thought that I'll share some of the knowledge that I've gained in the area of NLP. So the title of my talk is Breaking the Language Barrier. So now to set the agenda, so the talk would roughly take about 45 minutes. I should have about 10 to 15 minutes at the end for Q&A. So it would be perfect if you could just hold off on your questions. We should have enough time for that. So we'll first get started with setting the context as to what is natural language processing. I think all of us have heard this buzz acronym NLP, and it's kind of nice to formally define it before we get started. Then we look at some of the common NLP use cases that we have come across in our day-to-day lives, and many a times we don't even realize it's NLP working under the hood to power some of these applications. Then we look at some of the APIs that we have. So I would focus on, obviously, most of the APIs available from Microsoft. There are APIs from Google as well as Amazon. So there are some links to some of them as well. So once we have sorted out and explained what NLP is, then we'll get into the main topic of the talk, which is machine translation. So we'll first get started with defining what is machine translation, MT for short. Then there have been a few waves in the evolution of machine translation to the stage it is right now, which is neural machine translation. We'll go through those in a couple of slides. Then the applications of machine translation. So some of those we already cover in applications of NLP, and it's a subset of that. The next topic is a little theoretical. It's about defining what are language models. I believe it's good to have a little bit of this theoretical backing before we dive into what is neural machine translation. So those two sections would end up being a little more theoretical. And if you're interested in learning more, there'll be links to papers and videos that you might want to look at. To wrap up, we'll actually do an end-to-end sample use case, which uses both speech translation and as well as options to customize if you do not want to actually build the model from scratch. Towards the end, I'll actually have a couple of slides with some useful links that I've actually read, blogs, polls, papers on arXiv, etc. Okay. So let's first get started with defining what is NLP, natural language processing. Okay, so most of us know NLP is the branch of artificial intelligence that deals with the interaction between computers and humans using natural language. Just like how two human beings talk to one another, it's using natural language. The ultimate objective of NLP is to read, decipher, understand, and make sense of the human language in a manner that's valuable for both parties. So it's natural for me to talk to a computer device in a natural language as opposed to having to code or write. So think of devices like Alexa, Cortana, Siri, etc. And then if the device can understand my natural language, it just makes the interaction so much more natural. Then most of the NLP techniques rely on machine learning to derive meaning from human language. It's very difficult to have rules for every single interaction between a human and a computer. Now, throughout my slide deck, I actually have links to blogs and papers and things that I might have actually looked at when preparing these slides. So if anyone's interested in these, might be good starting point. Okay, so what is NLP used for? So I think the very first time I think of NLP, I think of predictive text. So I think of my iPhone, or if you're using Android or any device, you have predictive text that pops up just over your keyboard. So on the right-hand screen, here is an example of someone writing an email, and then the moment you kind of type the word YOU, it immediately prompts, are you trying to write yours, etc. So this is the most common application of NLP. And I think we've seen this for WhatsApp messages, Facebook, everything. They have this predictive text coming up. Then some of the other common applications that we come across is when we use either Google search, Microsoft Bing search, and we have the little search box where we start typing. So here is a search where I was trying to look for some relevant links on deep learning. So I start typing out what is deep learning, and LE. The moment I actually type LE, immediately it starts to prompt, and it also gives me other things. Are you looking for deep learning? Then some of the other common searches are, what is deep learning software? Are you looking for deep learning AI, deep learning in education? Many a times when we actually, at least when I search and other people search, we're not absolutely sure what we're searching for. We have a vague idea, and this kind of helps you determine what you're actually looking for. Then some of us have used Google Translate, Bing Translate. Here's an example of Bing Translate where I know English and maybe I'm interested in trying to greet somebody in French. So, I mean, I simply type out hello in English. It automatically detects that the text that I typed in that text box is English, it's detected. And then I kind of say, well, I'm interested in how to say this in French. So it says, it gives you the script. The script's very similar to English. I can read it, so that's easy. So, and if I don't know how to pronounce it in the native script, obviously a newcomer would not know that. So you also have the audio option where it tells you that it's bonjour. And it also gives you other ways of saying hello in French. So it says bonjour, hello, hello, etc. And also options of how to use it in a sentence if you're trying to learn. Then these are slightly more involved examples where natural language processing is the driving force behind some of these applications. So here on the leftmost part is a screenshot of a marketing document, and there are little bullet points which kind of summarizes the document in a few bullets to kind of tell you that, yeah, I mean, it takes about 4 minutes to read this document. Well, if you have time between meetings or if you have about 5 minutes, you should ideally be able to read this document. And at a glance, these are the summary bullet points. Then the second screenshot in the center is where I was browsing my LinkedIn feed and there was an announcement about a new Microsoft office in Houston. So, well, I was excited to hear about it. So I say thumbs up, I like it. And then immediately on top of the like option, you have, text that prompts you to kind of like add a comment. Are you inspired by this news? Are you happy to help with the setup? Is it a well-deserved thing, etc.? The third is Bing, where you can customize the screen, and then you have, I think it gives you all your meetings as well as summary of the documents and your profile and things like that. So you can actually customize it using what is relevant to your use case. Okay, so now to quickly summarize all the images that I took screenshots and showed you. So we do know that word processors such as Microsoft Word, Grammarly, they employ an NLP to check grammatical accuracy of text, SMSs, etc. Then we looked at language translation in terms of Google, Bing Translate. Then very often when we call customer care centers, we rarely talk to a human agent right away. So we have the IVR systems, which is the interactive voice response applications that help route our request to the right person by asking us a bunch of automated questions as to what is your request, do you have an account with them, etc. Then some of us do use personal assistants such as OK Google, Siri, Cortana, Alexa, where we do talk in natural language. Okay, so if you think of standard natural language processing tasks, NLP tasks, they can be split into two broad buckets. One is the natural language understanding task, and the second one is natural language generation. So some of the examples we looked at previously falls into two different categories. So when you think of natural language understanding, the goal is to classify text, determine the sentiment of the document text. Then you might want to determine entities within a sentence or a document in terms of name of a person, name of a place, etc. Then maybe question answering, when you kind of type a question saying, how is the weather in the city today? That's the question, and you expect the response from the agent. Then entailment is pretty much like, do one sentence follow the other naturally? Then sentence similarity. So then the other thing is natural language generation, which is language translation and text summarization. So we looked at the summarization in terms of the Word document, and language translation is actually the focus of our talk. Okay, so let's kind of first define what is language translation. So machine translation is the task of translating a sentence in a source language to a different target language. So, I mean, this is a screenshot that I got from one of the Statistica websites where they have an estimate of how many first language speakers are there by language. So, I mean, all of us know there are over 7,000 languages in the world, and the most spoken in terms of first native language speakers is Chinese, and you have Spanish, English. I don't know if this is a data chart, but I just got it from the Statistica website. Then in terms of websites and the content that gets generated on the internet, you do, however, see that more than 50%, half the data is text and websites in English. So you do see the disparity between what's actually spoken and the text being generated. Okay, so now that we've defined what is natural language processing, the types of, natural language processing, some examples, now let's get into machine translation. Okay, so we already defined what is machine translation. So to quickly reiterate, here is another screenshot of me trying to translate text in English, which is hello, to two different languages. One is in Hindi. And obviously, if you don't know Hindi, you're not going to know how to read the script in Devanagari. So then they have a transliterated option right below, which is easier to say. So it says it's namaskar. If you do not know how to say it, they have the audio button, likewise for French. Okay, so this is something that we looked at earlier. So like we said, most of the content that gets generated is in English. And if you look at what is that content that gets generated on the internet, bulk of it is primarily in just one language. So you have very little parallel corpus of data, and you typically want to have your website catering to multiple audience and who understands different languages. That's where all this machine translation comes in. So now this is another table on the most spoken languages. So I think most of us guess that it's English followed by Mandarin, Chinese, Hindi, etc. So we do know a bunch of people speak different languages. Not everyone knows English, but we do want to cater to everyone's needs. Okay, so now why do we need machine translation? So it's essentially to augment human translation productivity. So if you think of content that gets generated in Facebook, Twitter, Instagram, etc. So the content gets created really quickly at a very rapid clip, and it's not practical to have a human translator in the loop for these scenarios. So you do want something that automatically does the translation to the best of its abilities. And many a times human translation is just it's too expensive. So if you think of some low resource languages, often finding and hiring translators is difficult and expensive. And like I alluded to earlier, there are more than 7,000 living languages in the world, according to Washington Post. So it's impossible for us to have experts in all possible language doing the work manually for every possible scenario. So we need some sort of automation and computer processing in the back end. Okay, so now let's think of how machine translation actually very nicely enhances our productivity. So here is an instance where I actually got an email in my mailbox, and on the left panel is the screenshot is where that was the original email, which was in French. So, I do know a little bit of French, but not as much. So the mailbox setting automatically detected that most of the emails that comes into Jaya's mailbox is in English. So maybe she prefers to read this in English. So I have highlighted that red box where it says, would you just automatically like to translate everything to English? So this is how it kind of just saves me all the trouble of having to copy and paste content from this email into a Google or Bing Translate and find out what the email refers to. Another one is, I think, if you're trying to learn a new language. So I think some of us are interested in learning new languages, and that's where I've come across this app called Duolingo. So this is very nice how Duolingo actually uses Amazon Polly to power the entire speech to text and translation work. So it's a really cool app where these are some screenshots, someone's trying to learn Spanish, and then, it kind of gives you the audio clip, and then you're supposed to type out what the translation is, or the other way around. You might actually hear the content and you have to type it out in Spanish. So this is a really nice way of how machine translation can get used in apps. Okay. So now let's get into how did we reach the current state of machine translation. So it's obviously evolved and gone through a few phases. So the main phases that you think of is we first got started with something called rule-based machine translation. So I think that completely makes sense. You have a bunch of rules generated by expert linguists who understand the two languages or multiple languages. They generate a whole bunch of rules in terms of syntax, gender, plural, singular, etc. But this is not really scalable, but that's what was used from 1950s to 1980s. Then a bunch more examples came up, and then people tried out something called example-based machine translation. It was only in the 1990s, for about 15 years, that people actually, based on these examples, tried to use some sort of statistical machine translation. So things like, word-based, syntax-based, phrase-based models. And then it was just the last 5-6 years that neural machine translation gained a lot of momentum in terms of RNN, LSTMs, encoder, decoder, and encoder, decoder with attention. We'll get into that piece towards the latter part of this talk. Over the next couple of slides, we'll actually just quickly review what statistical machine translation is and neural machine translation. Then we'll get into what are language models. So statistical machine translation is essentially word-based, phrase-based, syntax-based translation, which also takes into account of word alignment between the source and target text. So if you see that many a times if you translate from one language to the other, the number of words in the source text as well as the target text do not have a one-to-one mapping. Sometimes even the order of the words flip. And that's what makes this entire machine translation so much more challenging. So you essentially have a source language model, then you have a translation model, and then you have a decoder. That's the entire setup for statistical machine translation. So obviously you need to actually maintain all these different models, word, phrase, syntax, and a whole bunch of things. So this is a little complex. If you end up changing a piece, you might need to go the whole route and change a bunch of things throughout the entire network. That's where machine translation is just much easier, because the approach to modeling is the entire machine translation is handled via really big artificial neural network. So there's an end-to-end encoder decoder structure. So here is, I believe this is a Turkish sentence, and you're trying to convert that into English. So like I said, throughout, I've actually put in links if you're interested in reading anything more. Okay, so now let's actually look at some of the applications, the formal applications in terms of APIs and what we actually have. So one of the things is you might need to first even detect the language. So many times you see text in a different language, you do not even understand the script. So how is it that you'll know which of the 7,000 languages it is? So here is the text that is in a script that I do not understand. So it automatically detects it as text in Tamil, and it converts it into English, and it says, well, essentially the text says hello in Tamil. Then you might want to have one API call which translates the text into multiple languages. So here's hello in English, where you're trying to translate it into French, German, and Arabic. So it gives you a salut, hello, and marhaba. Then you also have the transliteration, like I showed even in the Hindi case, where I may not understand how to read the native script. So it converts words and sentences from one script to another. So the script is something that I can actually read. Then you also have the bilingual dictionary where you can search for examples of human translated sentences and how to use it, synonyms, etc. Okay. So now we do offer a bunch of APIs straight out of the box if you'd like to try. So one of them is something called the cognitive services. So you have a bunch of APIs available. So you have for decision, language, speech, vision, web search. So the area that we are focusing on is language. So you have a bunch of options for immersive reader, language understanding, Q&A maker, text analytics, as well as translator. So we would focus on the translator option. Well, in terms of support of languages, it keeps increasing. So at the time that I took the screenshot, it was 60, maybe it's more. Okay, so then we have the translator API, where essentially the API, it has broad language covering. So I think they say in this one, about 70, and then it's customizable translations. If you need to do that, it's production ready. So this API can be embedded into any of your applications, and there's security. So you don't have to think about, is my data getting used for any purpose other than the translation? So you have the client app, web page, then you make a call, and then to the web API, and then you get the translation back. Then the other options also text analytics. So in this, the only piece that is relevant for this talk is the robust language detection. So this is just a little more application in terms of it does a little bit of the natural language tasks like broad entity extraction, sentiment analysis, again, flexible deployments. If you want to try this, just go to the website, put your text in the text box, and it analyzes it saying, well, this is the language is detected to be English, as well as these are the key phrases, sentiments, etc. Okay, then we also have a translator app. If you need to download it, have it on your mobile device, and you can use it on the go. Okay, so the next thing is, let's actually get into the more theoretical piece, which is language models. So I think some of these basics will help you if you're interested in the entire domain. And there are links to the archive papers if you want to learn more about it. So the goal of any language model is to compute the joint probability of a sequence of words. So the probability of word 1, word 2, word 3, so on. So we do not know how long the sentence is and assume that it's just 4 words in a sentence. So you're trying to compute the joint probability of word 4 occurring, given that words 1, 2, and 3 has occurred. So think about something like, I am attending NDC today. So maybe you have typed I am attending, and then it has to try and predict the next few words. So the model is built to compute such probability of a sequence of words or conditional probability. So some of these applications, we've actually seen screenshots of it. So one is machine translation. So many a times when you translate from one language to another, maybe the word big and high is similar in some other language. So however, in English, you would not say, if you translate, you're not going to say high mouth. It makes sense to have big mouth as opposed to high mouth. Then speech recognition. So many a times when we talk to these devices like Alexa, Siri, I might say, I love reading. And then maybe there's an awkward pause when I say read in, and it captures it as I love read in, as opposed to that single word read in. So then it kind of helps correct that and say, well, I think you're trying to say I love reading, And then spelling correction. So many a times when you type something out quickly in terms of messages and stuff, you have, you might mistype. I mean, typos are there all the time. So maybe, he types TYESP. So it kind of says, well, in English, TYESP doesn't sound right. So maybe you're trying to say types. I do agree sometimes when I actually do use, type, and it kind of autocorrects, and it's sometimes annoying because that's not what I'm trying to type. And it just prompts something. So the approach essentially is you're using chain rule, where you have the probability assuming there are only 4 words. Probability of word 1, word 2, word 3, word 4 is essentially probability of word 1 multiplied by probability of word 2 conditioned on word 1 having occurred times probability of word 3 given word 1 and word 2 has occurred times probability of word 4 given word 1, 2, and 3 has occurred. Okay, so then let's get into the definition of sequence to sequence. So this is where, in terms of translation, the input is a sequence of words and the output is also a sequence of words. So in terms of applications, we know that speech recognition convert audio to text as well as translation. Here's an example of trying to translate English to French. So you're trying to convert Mary has a little cat to, French, which is Mary a un petit chat. So those are examples. So now let's get into how sequence-to-sequence learning was solved using neural networks. Now, this started in Google about 6-7 years back, 2014, where they figured out that deep neural networks work well with label training set. They cannot, however, be used to map sequences to sequences. So then they also realized that deep neural network was applied to problems whose input as well as target could be sensibly encoded with vectors of fixed dimensionality. So the moment you see fixed dimensionality, you realize that, well, this is not really feasible for language translation. So like we said, the number of words when you translate from one language to the other is not necessarily a one-to-one map, and the order flips, etc. So sequences in general pose a challenge for deep neural networks just because they require the dimensionality of the input and output to be known and fixed ahead of time. And that's not always possible. So if you want to read a little bit about sequence-to-sequence learning, there's an archive paper that is worth investing in. Okay, so this is the encoder-decoder architecture. So essentially you have input text, and then your goal is to get the translated text. So the encoder essentially reads this input sequence one time step at a time to obtain a large fixed dimensional vector. So that's that little box in red with a bunch of numbers. Then essentially what the decoder does is it extracts the output sequence from this context vector, the vector in the middle. So essentially you have a variable length input sequence, and you have a fixed length context vector and then a variable length output sequence. Now, the characters of an encoder-decoder architecture is it can capture linguistic regularities, rules and phrases, etc. It obviously did improve translation performance, which is good. And it allows for continuous spaced representation to learn phrases that preserves both semantic and syntactic structure of phrases. Then obviously a simple encoder-decoder structure does have some limitations. So this is vanilla sequence to sequence and long sentences, typically something more than 30 words. They tend to have poor results due to that fixed dimensionality for the decoder. So that's where people came up with something called an attention mechanism. We'll get into what attention mechanism is in the next slide. Then the next part is also that, with long sentences, which part of the source text do I need to focus on for translation? How much attention needs to be paid to different parts of the sentence? So that's where you think of some sort of weighted average and building a context vector. So we know the problem with a simple encoder-decoder, and they came up with this encoder-decoder with attention to solve that problem. So we know pure encoder-decoder structure only utilizes the last output, which is not optimal for our scenario. It compresses all the necessary information of the source sentence to a fixed length vector, and that makes it very difficult for neural networks to handle long sentences. So the general idea with attention is to extend this encoder-decoder architecture by allowing the model to automatically kind of soft search parts of the source sentence that are relevant to predicting the target word. So in the next slide, there is a very nice visualization which kind of helps understand this entire attention mechanism. So this figure is from this website. So this is an example where you're trying to convert English text to French. So as you can see in the English sentence, there are about 7 tokens. I just want to have a sister. And if you look at French, there are only 6 of them. So it's always, you cannot predict how many words are there in the target language when you translate. So if you look at the word I maps very heavily. If you look at the blue line, I maps with je. And if you look at the word sister, it maps with the word saw. And the rest of the words, there's some amount of weightage between all the other words. So this visualization just kind of makes it easier for us to understand that. Okay, now that we're done with language models, now let's get into what is neural machine translation. Okay, so like we said, based on all the theoretical piece, there are essentially 2 stages. The first stage is encoding and the second is decoding. So if you look at the encoding phase, what you're trying to do is model each word based on its context within the full sentence. And then the second stage is decoding, where you translate this word model within the context of the sentence. Okay, so let's look at this in a little more detail. So here is an English sentence that you're trying to translate to French again. So in model the layer 1, each word is modeled in context of the full sentence. So what you do is during training, the neural network creates a 500-dimensional model of each word in that sentence given the language pair. So the language pair in here is English to French. So it looks at things like word type, whether singular, plural, gender, formality, etc. Then what it does is the neural network creates a 1,000-dimensional model of each word given the context. So this process is repeated for every word in the sentence. So the sentence in here is the blue house is something. Long sentence. Then what it does is it essentially adds many more similar layers 2 to n, because multiple layers allow for better contextualization of the given word as part of the sentence. Then it comes up with this final input matrix. Then, as we know, we need this attention algorithm for better translation. So attention defines the word order translations based on context and which word maps to which one in the target language. So then finally you have the decoder layer, which translates the word with the context awareness for the particular language pair. So if you look at this, the translation layer, based on the 1,000-dimensional sentence, context as well as attention, starts to translate one word at a time. So it knows that the translates le in French, and then it knows that in English it comes as blue house, but in French it's maison bleu, so it's like house blue. So it knows the entire context and the switching of words, etc. Okay, so now I think we should actually wrap up this segment on defining some of the advantages of using neural machine translation. So obviously it's end-to-end training. All the parameters are simultaneously optimized to minimize loss function. Then there's distributed representation, better sharing of word phrase similarities, better exploitation of context, as well as more fluent text generation. So we've noticed that deep learning text generation is of much better quality these days. Okay, so now let's actually look at Microsoft's translator service. So this is the speech translation. So you essentially have a client app which captures the audio segment, and then you invoke a web API and you get back the translated text as well as speech. So machine speech translation, you send the voice, receive translated text, and it's optimized for conversations. It's also customizable. So many a times out-of-the-box solutions do not fit well in all the scenarios. So here is how the speech gets captured by something called an automatic speech recognition. So maybe I'm trying to talk to my Alexa Cortana device and I say, can you hear me? So many times when we talk on a regular basis, we might repeat a word. It may not be grammatically right. So you need to kind of clean this out a little bit. So it realizes that I have accidentally repeated the word can 2 times. So then the first thing it does is gets rid of one of those can. Then if you look at the word here, H-E-R-E, in this context, it should ideally not be H-E-R-E. It should be H-E-A-R. So it corrects for that. Then it knows that this is more like a sentence. I'm asking the device a sentence, can you hear me? Or on the phone, I'm talking to someone saying, can you hear me? So then it capitalizes and puts the question mark. So once that is done, essentially it gets into the machine translation, and this is, I believe, English to Japanese. So then it gives you the translation as well as it gives you the text to speech and the audio clip. Now, throughout the process, you can get partial transcripts, final transcripts, and translations. So maybe sometimes it's not perfect and you might want to check it and make corrections and use that data to retrain the model again. There is obviously an option to customize this at various stages. You can customize speech, translator, as well as voice. Okay, so now customization is one of the focus areas of this talk, where we look at how can we customize translation. So we do know that general models have limitation for industry terminology. So if you're thinking of terms in the healthcare or law or finance, so many of these terms are so specific that it doesn't come in the general corpus of Wikipedia or other data that we use to train our models. So that is where you might want to customize and use custom translator. Now, obviously, training neural machine translation models from scratch is complex, is expensive. You need a lot of GPU powered machines, and you also need a lot of data, which may not be available for all the companies. And you also need the domain expertise. So you have very few people who actually know how to do this. So you might as well just leverage the work that's already available. That's where custom translator comes in, where you can use pre-trained models and then adapt them with some customer data. So they kind of say that as little as 2,000 parallel corpus of data, sentences is all you need to customize the model. And it's easy, cost-effective, and fast. I actually have screenshots of how easy this is to do. So if you think of customization, so you typically measure a model in terms of something called a BLUE score. That is bilingual evaluation understudy. So typically a generic model has a BLUE score of roughly 20 to 30. A human's really good. So that's, let's say, between 50 and 75. Custom translator model, which is industry specific, is a good compromise between the two. It's like 30 to 45. And if you have more data, it just might improve and become maybe even as good as a human. Okay, so how does this entire process work? So this is essentially just a 4-step process. So here you're trying to convert French text into English. And if you look at the general API, it gives you a translation. But maybe the words and the way it's translated is not perfect. So that's why you actually want to use the custom translator. So the 4-step process is, the first thing is you upload your parallel corpus of data. So here you have your French to English, about 2,000 sentences, you upload it, and then you train the model, and then you get your custom model. Then to test the efficiency of the custom model, you obviously would have held out some of your data for testing, which is independent of your training, and then you compute the BLUE scores. So in this case, it says that the general model had a BLUE score of 22, the custom model has a BLUE score of 26, and you see that little bump in performance. So your custom model is slightly better than the general model. And then it's very easy. It's a one-click deployment. And then you can test both side by side, your generic model and custom model. And typically your custom model ends up being much better. Okay, so now how do we get started with this? So you actually have something called custom translator. So the link's there. There's some documentation. So once you log in, you just essentially are trying to create a project. So you have to give it the project name, description, pick the pair of languages. So maybe you're interested. I think I tested it out for Hindi to English and English to Hindi. And then you need to pick the language pair, then the category. So you can have a general model, an industry-specific model. So they have a few things, and you just give it the category, descriptor, project label, just hit on create, and then it creates the project for you. once the project's created. So I think this example is you're actually the category is technology and you're trying to do English to French. So then you need to upload your training document. So it's just, you have to give the parallel copy. So it says the source is EM, English, target is FR, French, and it supports all these different types, the TXT, HTML, HTML, PDF, etc. And then you upload the data. So I do think that, yeah, just about, yeah, I've tried it with more than 2,000 sentences and some dictionary pairs, and yeah, you have a bunch of options. Then what you do is it trains. So it's just a one click. You hit on train. It takes a few hours depending on how much data is there, etc. And then it kind of says, well, the status is, so you have the data tab and the model tab, and then it says the training is succeeded. It gives you the blue score. It gives you a baseline. Tells you, well, this much data was used for training, these many sentences. This was used for tuning and testing, and then you have that one button for deployment. So essentially, what is that you're able to deploy to whichever region your customer is based and take advantage of this one-click deployment. It's very simple and easy to use. Then is, yeah, so next is I'd like to actually wrap up with some useful links. So let's actually look at that. So the first bunch is, I think these are some blogs, the machine learning, then what is LSTM if you need, then there's a Stanford lecture series on language modeling, there's a YouTube lecture series on NLP, then our team has a few blogs, then Jay Alamar is really good at explaining the sequence models with attention. He has some very user-friendly blogs as well as a YouTube channel. Then these are the more technical papers, primarily for the language model section as well as neural machine translation. So they are all in archive. I mean, some of the papers are long, but it is kind of worth taking the time if you're interested in learning more about it. Then is, yeah, some of our product links. So you have Microsoft Translator, then Microsoft Translator Live, and then there are technical support forums. And I think Azure came up with a blog which said that they support even custom voice and text-to-speech and updates like that. So I think these are some screenshots for Microsoft Translator, Office Lens, and that is pretty much what I had. I think now I have about 15 minutes for questions, if anyone has any questions for me.